On this episode of Built to Last, we are tapping into best practices for renewable energy and how the building industry is playing a key role in promoting alternative energy systems. Next on Built to Last. Almost daily, we hear or read a new report about the environmental impact of petroleum-based fossil fuels and the detrimental role they play in greenhouse gas emissions and global warming. Along with the building industry, the millwrights of the United Brotherhood of Carpenters, or UBC, are leading the way in taking a holistic approach in combating these adverse environmental developments through training that is focused on renewable energy technology and systems such as solar, wind, biomass, and hydroelectric. These renewable energy systems are where this 21st century industry is heading, and a crucial effort to preserve our natural resources and protect our planet for generations to come. Hi, Michelle. I appreciate you inviting us out here today.
Hi, Bruce. Thanks for coming.
Looks like we got something pretty exciting going on here.
We do. We've developed a project here with the carpenters in an effort to develop workforce training, a workforce training program for the apprenticeship. And we talked about developing this project where we would install a 10 kW working model of turbine, and this is actually a Ventera turbine manufactured in Duluth, Minnesota, so American made. And then we would also have a practice turbine that we would have for the instructors to use with their classrooms to train apprentices on the inner workings of the turbine. And we would be on site today training instructors. The process of the tower foundation has been completed.
Okay.
The tower that we're using today is actually a Roan tower, and it's manufactured in Peoria. So we're using a locally sourced free lattice standing tower, and as you can see, it is going to be erected and connected to the base via 3 piers, a tripod type example, and it's similar to what we would have seen back in the day at the old windmills out on the farm. So,
okay.
This type of tower there are 3 types of towers: the guide lattice, and then the guide wire tower, the freestanding lattice, and the monopole. We chose this one because it's competitively priced. As far as the footprint of it going into the ground, a monopole would require a larger footprint down. This one didn't cost as much to be able to engineer the concrete. And so later today what we're going to be seeing is the blades being added to the turbine that has now been mounted to the top of the tower. And the electrical connections being finalized, and around 1 o'clock we'll be erecting the tower and commissioning for the first time.
Wow, that's going to be great.
The foundation for the tower is set. Now UBC millwrights continue their training in assembling the tower and turbine.
I assume a lot's gone in to take place to get this to today, this state, with engineering, height, and determining the conditions here?
Absolutely. There was siting that had to be done first. I actually did an official wind site assessment to identify the wind resource that we had available, to take into account the trees, to determine proper height of the tower. We always do a higher tower because we want to get into the wind stream. The way that wind works is when it hits an obstacle, then it's going to rise above that obstacle to get over it. So if we're not above that, we're not going to be in that wind stream and capturing the maximum amount of production that we can. We also had to do some environmental studies, some soil testing, things of that nature. The bigger picture of what we're doing here is being able to correctly train contractors to go out and take on all of that. But I'd like to take you inside and show you some of the inner workings that we can't see from out here in the field now.
That's great. Let's take a look.
All right, let's go.
While the UBC millwrights continue to prepare the tower and turbine outside, we went inside to gain a better understanding of the turbine assembly.
This is part of a program to teach our apprentices and journeymen on assembly of the wind turbine, of the power field. It's whether it's steam turbine, gas turbine, or wind turbine is a very large part of the workforce of today. And so we are teaching them the basics, steps, do's, and don'ts of proper assembly of the blades, of the pitch, of the brakes, all the innards of the wind turbine.
Okay, so actually they're going to be doing an install here?
Oh, yes, sir. Yes. Oh, this is a mock-up that we have made, and we can actually install the 3 blades, spin it in here. No, we don't hook it up to power, nothing like that in here. It is showing them how to properly adjust the pitch of the blade, the brakes, everything that the producer and manufacturer of these wind turbines wants.
Okay, so basically they're going to be going through all the steps that normally would take place in the field.
Yes. It's better to learn in here than out in the field. If you make a mistake, it's better to learn it here than it's out in the field.
And this is actually an operating turbine, so this could be an operating turbine in the field. So they're working with the real product, but doing it in a training environment. So they can then take that knowledge and transfer it out into the real world.
Okay, so what basically takes place? You look at kind of the blade, it has the fitting. Now is it, what were the steps that go through as part of this?
Well, the first step is out in the field is getting the head up into the shaft. We've already done that. And that's going to stay up there. Slipping the blade over the shaft up into the hole, locking it, putting on the secondary end part of the blade, adjusting the pitch to within thousandths of an inch, because that's where the efficiency comes in that blade. Then we get into the brakes and the clutch. And so then we pass that down to our apprentices as well as journeymen.
And it's very important that this be done correctly without that being set to that 1/1000th that he spoke of. It's possible that there would be blade failure in the field, and that's something that we don't want. So this is a skilled labor trade.
So yes, there's a lot of precision that needs to take place.
Absolutely.
Okay. So this is something that kind of becomes assembly, repair, so it really gets them very versatile on this type of system.
Oh, yes. Yes. When this is on the small scale basis, you see a lot of the larger ones in the wind proficient areas. But these here are becoming more and more seen.
Right.
Private and smaller sectors.
Sure. I mean, renewable energy is a very important factor. So this is something really, it's technology that's advancing and the training needs to be there.
It absolutely does. And we look at it from not only a perspective of the initial installation, but also maintenance jobs. There is minimal maintenance to this particular turbine, but part of what they're doing in this process will be to train their workforce to be able to do maintenance on turbines down the way. So we're really looking at the larger picture of job creation and having the skilled labor ready to go into this market and be able to fill that need. This is really the electrical portion of the installation that I'm going to show you now.
Okay.
What we have here exposed are the wind interface units. So the power that's coming in from the turbine is what we call wild AC. And so when it comes in, we need it to hit these wind interface units so that it can be converted to the rectifiers and then converted to what we call DC power, direct current, comes up through these inverters, and these inverters are going to then convert it to usable AC, alternating current, the kind we use when we plug into an electrical outlet.
Okay.
We have, in addition, we have this all hooked into a monitoring system that is going to allow us to, via the internet, be able to see real-time production of the system, what it's doing right now, what it's done historically, what it's done from the time that we installed the system. Each one of these inverters has its own breaker in the service panel as a means of disconnect. We also have a breaker outside located at the utility meter and also out at the base of the turbine.
Back outside, the UBC millwrights have progressed quickly in assembling the tower and turbine for the addition of the blades.
Hi, Joe.
How you doing, Bruce? Joe Woods, Ventura Wind.
Nice to meet you. I understand you could kind of tell us what's going on with the inner workings here.
Oh, absolutely. This here is called the VT10 Ventura Wind. It's made up in Duluth, Minnesota. It is the only military-grade wind turbine made in the world. It has a significant amount of recycled material in it, and all the bolts and everything is protected from rust. It's either made of high-strength stainless steel or zinc coated. So when it's brought down for maintenance 5 years from now, you won't see any rusting in it, unlike other models that are out there. It uses better technology with the hybrid stator, which allows us to use a lot less materials in the manufacturing. So it only actually weighs 580 pounds with the blades. And that also allows the cost to be much less. So our turbine costs less than any other model on the market, in addition to even beating out the Chinese models. So it's pretty significant. The technology helps us to enjoy all wind speeds. So it's got a 6 mile an hour startup wind speed, and it continues to produce power up to 130 mile an hour. Most wind turbines, they have to protect themselves, so they have to shut down at 50 mile an hour. And ours doesn't. It continues to work. Our patented governing system allows the outer portion of the blade to open and close, and it helps protect the wind turbine while still allowing it to produce peak power. So it's a really an advanced design and a maintenance-free design, which is extremely important nowadays with everybody's busy lifestyle and when we look at investment for businesses also.
Working together, UBC millwrights secure and adjust the blades and check the manufacturer's specifications for proper installation.
Now, I see they're starting to do the assembly here. What exactly is going to be taking place?
Right now, the blades are very specific on how they need to be set up, and that gives us peak performance. They're setting the governing system right now. The governing system allows the turbine to continue to work, like I say, in the peak production. It is centrifugal force.
Okay.
It was used back in the 18th century by James Watt on the steam engine. So it's been around that type of technology for a long, long time, very successful. The hybrid stator allows us to use a lot less material, and while still getting actually more power than a traditional stator. So it's a very, very intelligent design. The main frame is made out of 100% aluminum, recycled aluminum.
Okay.
And then the hub over here, that's made out of 70% recycled aluminum. There's recycled plastic in the blades, so it is the most environmentally friendly, not only in material, but in weight also.
Great. Now, I know that this is being done in this type of position. Everything, I assume, is assembled here, and then once it's complete, you lift it into place?
That's correct. Once this is all done, we put down the dome cover to help protect the mechanism from weather, and then the turbine will be raised and set into place and leveled, and that's it. You're done. It's all automatic after that.
Okay, great.
At the end of the day, it is another job well done by the UBC millwrights and a step in the right direction for alternative energy sources.
Now, Michelle, it's been a long day, but everything seems to be working out great. The wind turbine's up and it's running.
Absolutely. It's been a great day, great weather, and a wonderful culmination of about a year's worth of work to make today come to fruition. So thank you for coming and being a part of it with me today.
Appreciate it very much.
It's great to have you here.
Thank you. We're here today with Kevin Borja of Wind on the Wires, and we're going to discuss wind technology. Kevin, can you give us a brief overview of how wind technology is effective in today's use?
Sure, absolutely. So wind turbines integrate into the electric grid in a similar way that other generators integrate into the electric grid. Whereas instead of using burning something to create steam to turn a turbine, the wind turns the blades, and that goes into the nacelle of the wind turbine, and then that turns a gearbox and then a generator, and that generator produces electricity, which is then fed into a substation and into the electric grid. And so oftentimes we have wind being injected into the electric grid along with other energy sources like coal and nuclear and natural gas-fired power. And that helps us to have a cleaner electric grid that doesn't require the use of fossil fuels or other technologies.
So in terms of renewable energy, everybody kind of first thought is solar and wind. Is one more cost effective or energy productive, or does it depend on use and where it's located?
In general though, right now, wind is a little more cost effective on a large scale. Again, when you deal with a big technology like wind power, you're dealing with economies of scale that allow the cost to come down. Solar's a little bit more expensive. However, the costs for both wind and solar are dramatically decreasing. Just in the past 5 to 7 years, I believe we've seen around 50% cost decreases in the cost of wind technology, and similar numbers for solar. We're seeing the bottom just fall out of the costs of these technologies, and that's a great thing. It allows much more consumer access to these devices and these technologies, and it allows us to have a cleaner electric grid and less air pollution.
So what kind of determines what one benefits more than the other as far as these types of products, wind versus solar?
Sure, well again, oftentimes it depends on the site, right? You don't want to put your solar panels in a shady area, you don't want to put your wind turbines in an area where there's no wind. The same way that you wouldn't drill for oil in a place where there's no oil. And so oftentimes it's all about the site.
Okay, and so what are the benefits overall? Can you kind of give us, somebody decides that, these wind turbine farms and things like that, what are the benefits from that to a consumer and as a whole to the country?
Yeah, absolutely. So, I mean, the primary benefit, of course, is no pollution. Most energy sources require the combustion of some kind of a fossil fuel. Obviously, that's not required with wind energy technology or solar. You're able to, once you put up a wind farm, it's generating electricity without harmful nitrogen oxides or carbon emissions that are contributing to global climate change. And that's the primary benefit. But in addition, there are other benefits people don't always talk about. So for instance, anytime that you're burning most fossil fuels, and a lot of fossil fuel generators require the use of an awful lot of water. That water, of course, makes steam, which turns a turbine. With wind, there's no water use. With solar, there's no water use. That's a very big benefit for parts of the desert Southwest and California, which are facing serious drought concerns right now. And so to have kind of electricity that doesn't require the use of water can be big.
So, and then too, the economic benefits from this must be pretty great then.
Yeah, absolutely. I mean, these are very large pieces of infrastructure, and so that requires a lot of construction. Oftentimes, if you're, turbines that we're building today to the tip of the blade are as much as 500 feet. That's a very, very large construction project. And so the construction jobs from turbines are pretty significant, as well as the manufacturing jobs. It takes several hundred, if not over 1,000 components in every wind turbine. Those have to be manufactured somewhere. We have to roll the very large steel towers that the turbines sit on. And so there's a lot of construction jobs, there's a lot of manufacturing jobs involved there. Once they're built, the turbines are often built on land that's leased from farmers or ranchers or landowners. Those folks get a payment. They get a payment of often several $1,000s a year to just host a turbine. They don't have to do much work, and they can still continue to farm or have cattle or livestock around that turbine. And that's a real benefit to them. That allows them to have a price hedge against possible crop losses or commodity decreases in agriculture. And then you also have significant millions of dollars being paid in property taxes to those counties that are hosting the turbines. All of this comes together to be a significant benefit for both workers and landowners and just citizens of the areas where turbines are hosted.
So in closing, how do you see wind becoming more an important factor as we're moving forward in time and looking for renewable energy resources?
Sure, so increasingly utilities are getting much more comfortable with renewables and wind in particular. We see utilities getting much more understanding of predicting wind energy's output. So wind energy doesn't produce power at a consistent rate. There are times when it produces more and times when it produces less. It is a variable production technology, but it's very predictable. And utilities are getting much more used to incorporating and integrating that variable generation profile into their electric portfolio. And so we're seeing utilities get much more sophisticated with their abilities to integrate wind, and we're seeing a lot of really amazing things happening with transmission construction. The strongest winds in America are in the Great Plains, but that's not where our population centers are. That's not where our load is, our electric load. But there are some amazing things happening right now with building those long, high voltage transmission lines from the Great Plains into the areas where the population centers are. And that's going to allow us as a society, as a country, to access that great wind resource that's in the center of the country. And I think in 10, 15, 20 years, we're going to be operating this country on a significantly larger amount of wind power than we are today.
Training is very important. If you're going to hire us and the foundation is not going to feed your windmill, you're going to waste time and you're going to waste money.
Over at the Carpenter's Apprentice and Training Center, the foundation for a wind tower is studied, built, and critiqued by the instructor, Isidro Barrios. On the job, Ray Chamberlain knows that this type of training is invaluable for addressing unique construction challenges and safety concerns.
What's going on behind me here is we have a group of apprentices training to build the foundation of a wind tower. Right now they're doing it on a floor in our training center. This would typically be done in a hole on a job site that's anywhere between 60 and 80 feet deep.
Apprentices practice setting up a perimeter form and its required footing with anchor bolts. In order to ensure the anchor bolts match the specified blueprint elevation with precision, total station technology is used. By design, the performance of the foundation is as important as the wind turbine itself.
It's got to carry its own weight and also the side pressure. The side load is just tremendous amount of force, so that's why the foundation is so big in order to carry and balance all the weight.
Probably the two biggest concerns in erecting a wind tower would be on the carpenter side of the work. The carpenters typically put the foundation in the ground, and that hole is a very deep hole that foundation goes in. So certainly there's possibilities of slips and falls.
These monolith towers that dot many country roads where farmland and renewable energy share the same geography are modern marvels. Special attention to the foundation is critical when you consider that the base of the structure must secure a multi-million-dollar turbine against the elements all year round.
Typical towers are over 300 feet tall, and climbing 315 feet twice a day, 100% tie-off is required, and falls are certainly the biggest hazard associated with building wind towers.
For millwrights and carpenters, training is focused on construction. Additional safety classes are offered to minimize risk on the job site. To achieve safety certification, craft members are instructed in a wind turbine rescue.
That would be put into place for any craft member working on the erection of a wind tower that was at the top of it and unable to come back down. Rappelling isn't involved in the climbing of a wind tower. All wind towers have an internal ladder that goes from the floor to the top. So any climbing that's done inside of a wind tower is always done on a ladder.
While training is monitored and practiced by the same trade, the construction of a wind tower requires the collaboration of two crafts, carpenters and millwrights. Together, they form a composite crew.
Carpenters typically do the form work associated with the base of the tower, and millwrights typically work with other craft in the erection of the tower. Millwrights, via our training and our certification with hydraulic tensioning tools, we would tension the tower as it goes up. When the head is put on the tower, we would set the head and tension that head as well. And we also build the rotor system, and we put the rotor system on it and then align all the components associated with it.
Everyone knows what a torque wrench is when they get a certain amount of torque on a bolt when you tighten it. Well, you get some bolts in power plants, I mean, they're hundreds of pounds of PSI. Well, you can't really pull that, so they have a hydraulic torque wrench. And so when you're dealing with nuts and bolts that are 6 inch in diameter, that's a lot of torque you got on it. So they have high torques, that will get the correct tensile strength on it, and, or foot-pounds, I should say, and using a hydraulic torque wrench. You know, we train our millwrights on that, you know, the safe use of them, because if you don't use it safely, you could, you know, someone could get hurt seriously on those. In our shop, we have a little mock-up with a pipe and a flange with like 20 bolts on it, and they use a small 3/4 inch high torque head, but you know, they come in, you know, bigger, larger sizes and different types of heads too. They have some that don't have a reaction arm, so the different types, you know, we have a couple different in our shop, and we teach them how to set it up, how to use it, and how to read the chart so they get the correct torque on the size bolt that they're torquing. On that, they use a lot of power plants. You know, we have a lot of bolts on there that, you know, they got to be torqued to a specific tightness. They use them on windmills. A lot of, you know, like I said, power plants, windmills, and there might be other applications. You know, normally structural steel, they probably won't. They're not as, you know, doesn't require as much torque as something like in a turbine.
Whether you're at home or at work in a commercial building, you can see the intersection of sustainable practices and the work of skilled carpenters, together making our world built to last. I'm Bruce Obora. Thank you for watching.
Visit the Built to Last website to learn about these topics and more.